Chapter 4, Atomic Structure, and we're on Section 4.1, Defining the Atom. Here's our objectives. 1, be able to describe what Democritus' ideas were concerning the atom, explain Dalton's atomic theory, and what instrument do we use to view atoms. If we're talking about atoms, first of all, just be aware that everything, all matter, all of that stuff is composed of atoms. That's what makes up everything. And the atom is the smallest particle that you can have and still have the same identity, still do the same chemical reactions and all those things. You can break the atom down smaller, but it no longer retains those properties anymore. Then it becomes something completely different. If we want to go way back, kind of really the first person to come up with this idea, this atomic theory or anything, was Democritus. And he was a Greek philosopher who lived back in 460 to 370 BC. So quite a ways back, 2,500 years ago. And that was when the first idea of atoms came about. So he was kind of the first guy to ever suggest it. And he believed, the Greeks at the time, and him, believed that the atoms were indivisible. You couldn't break them down any farther. That was the smallest thing you could go. And they were indestructible. So they kind of said, well, the atom is, if you just keep dividing things in half and in half and in half, eventually you got to get to the smallest thing, one thing. And then when you get there, that's an atom. And his belief, or their belief at the time, was that you couldn't get any smaller than that. And that idea stuck around for quite a while, till, the 1800s. And then we've got a little bit of movement here on the atomic theory. A guy named John Dalton, and he was actually a school teacher, chemist in England, and he kind of started the beginning of the atomic theory, really. So his ideas were, used to kind of transform what Democritus thought, turn it into more of a theory, versus anything with the Greek time. All they ever did was just kind of discuss it, never did any testing, never did any experimenting, those kind of things. So Dalton did do some of that stuff as we started to come up with the atomic theory. And he comes up with 4 points. The first one, what he says is that all elements, everything, is composed of these tiny indivisible particles, these atoms. Atoms of the same element, so if we're talking about all atoms of carbon, they're identical, and they're different from any other element. So carbon atoms are different from oxygen atoms, or different from hydrogen atoms. So atoms of the same element are the same, atoms of different element, all of them are different. And you can either mix these elements together, physical mix, a blend, or you can chemically combine them. So we can have a chemical combination, or we could have a physical combination, is what he's saying. So a mixture, I could just take two things, throw them together. You did that with like iron and sulfur. You just threw them together. But, when I heated it in the test tube, it created a new compound. That would have been a chemical combination of those things. In chemical reactions, atoms are separated, they're joined, they're rearranged, but they're never changed in anything else. The atoms that were there in the beginning are still there at the end. So if I started with, a carbon atom at the beginning, there's going to be a carbon atom at the end, and so on. All right, let's talk a little bit about sizing up the atom here. And, we talked about this, if you divide it in half until you can't anymore, that's what we talk about for the atom. If you think of a penny, okay, just to kind of give you the idea of the size of an atom, in a penny there are 2.4 times 10 to the 24th atoms. In other words, that's a 2, a 4, and 23 zeros. That's how many atoms there are in one penny. And sometimes it's just hard to even think of numbers that big. I mean, write it out and you're like, I've never seen anything quite that big. Just to kind of give you an idea, there are approximately 6 billion people in the world right now. That's 6 times 10 to the 9th. We talked about the copper pennies, 2.4 times 10 to the 24th. In other words, in one penny, there are 4 trillion times more atoms than there are people on the Earth. There are a lot of atoms. And obviously, if there's that many, it has to have a very, very small radius. The typical radius of an atom ranges from 5 times 10 to the negative 11th to 2 times 10 to the negative 10th meters. In other words, decimal point, 10 zeros and the 5. So pretty small number. That's how big an atom is. So you would think, oh man, I probably can't get a picture of it. But right here, this is an example of a copper atom that they've actually taken a picture of. So we can actually get pictures of the atoms with something called a scanning tunneling microscope. Now, it can't actually give you pictures of like the electrons and so on. Kind of just gives you a shading of where those things are. Nowadays, we have the ability that we can actually move individual atoms around. In fact, if you look at things like integrated circuits and things like that, we are actually doing that at what's known as the nanoscale. That's nanotechnology. We can actually create circuits that are just a few atoms thick, and that means they can make them really small. That's why computerized silicon chips are so much smaller now than they were just even 5 years ago, especially more than 10 or 20 years ago. And so all of these things, you can use them in computer chips, medicine. It is very likely in the very near future they can take and inject you with these like nano robots, these really small robots that could actually go in your bloodstream, and they can, maybe have a camera on them so you could actually see, like if they're going to check out some cancer cells or something like that, or maybe even come in and target those particular cells and kill them rather than do radiation or chemotherapy. It could be much more targeted type of thing. That idea is not very far away. Probably you'll see that in your lifetime. So, we're getting to working with things at a very, very small scale nowadays. All right, there you have it, section 4.1.